Hello students, it's Mr. Nguyen here. Today we're going to be talking about the four different types of angles that are found when you're working with circles. The first type is called the central angles. These are angles that have a vertex in on the center of the circle. Um, Another type of angles you'll find is on the circle. These are called inscribed angles. The vertex is on the circle, so you just kind of find the vertex where it is. If it's in the center, they're called central angle. If it's on the circle, then we call them inscribed angles. And then you'll also find angles that are inside the circles, right? When two chords intersect, and then, of course, we'll find angles that are outside of the circle, like this right here, when two secants meet on the outside. So we'll talk about them, and we'll talk about the relationships that they have with the arc. So let's talk about the first one, central angles. It says here the measure of the central angle is congruent to the measure of the intercepted arc. Okay, so the arc that intercept or makes up this angle, uh, it's measured by the same central angle. So if the central angle is 70, the arc is 70. If the arc is 70 degrees, then the central angle is 70 degrees. Okay, so that's pretty easy to remember. Now, the whole circle measures 360 degrees. We all know that. If you have an arc of 70 degrees, this is considered a minor arc. Um, A minor arc, by definition, is anything that is less than a semicircle, which is 180 degrees. So the rest of this circle would be considered the major arc, which is larger than 180 degrees. So the major arc here is 290 because that's 360 minus 70. Here you have a circle with two diameters, and we have a given central angle of 140, and then they are also given us an arc, but the arc is not the arc that intercepts the 140. It's the arc that is next to that. Well, since this line right here is the diameter, which means this is a semicircle of 180 degrees. So we know that the angle right next to that is 40 degrees. Okay, so now we can set the angle 40 degrees equals to 6x minus 8. And then we'll solve this equation. We'll get the value of x. So add 8 to both sides. You get 6x equals 48, and divided by 6 to get x equals to 8. The next type of angle we're talking about is inscribed angles. And inscribed angle has a vertex on the circle. And the theorem says the measure of an inscribed angle is equal to half of the arc. Okay, so here's an example of an inscribed angle that is formed by a tangent and a chord. Okay, so angle x right here is the inscribed angle, and the arc that intercepts it, it's right here, right? Arc BA or AB. Okay, and that arc measures 148. So according to this theorem, x must be half of that, which is 74 degrees. Okay, and it works the other way too. If they give you the angle and they ask for the arc, you multiply by 2. So for example, this is an inscribed angle that it's on the circle. It's formed by two chords, right? And the angle happens to be 30 degrees. And we're looking for the intercepted arc. Well, if the angle is half of the arc must be 60 degrees. Another example, we have an inscribed angle here, and it's 3x minus 3, and we have the intercepted arc of 120. Well, if the intercepted arc is 120, the angle must be 60. So we'll just set the expression equals to 60, and we can solve for the value of x. Okay, 3x minus 3 equals to 60. Add 3 to both sides, and then divide it by 3 to get x equals 21. This is another example. Here we have the diameter FG. I know that because it goes through the center P. That means the arc for FG, this arc right here, is the intercepted arc for this inscribed angle X, right? But this arc, because it is a semicircle, that arc is 180 degrees. That means x is half of that, which is 90 degrees. Okay. The next type of angles we'll find are the angles that are inside the circles, and these are formed when you have two chords intersecting each other. So what does the theorem say? The theorem says to find this angle, you add the two arcs and divide it by 2. Okay, so it says right here, it's half of the sum of the intercepted arcs. So for angle 1, the intercepted arcs would be PQ here and RS here. So what this is saying is to find angle 1, you add the two arcs together and then divide it by 2 or multiply it by 1/2. Okay, and so let's say if arc PQ is 36 degrees and arc RS is 98 degrees, you will add them together and divide it by 2 to give you an angle 1 of 67 degrees. Now, notice angle 1 and its vertical angle on the other side are the same. So if you were to look for this angle, it would be the same thing, right? And notice when two lines intersect, you have two pairs of vertical angles. So to find the top and the bottom angle, you would subtract your answer by 180. Okay, and you will get the other angle because these are linear pair, which are supplementary. Okay. Is another example. All right, for this example, they're asking us to find this angle x here. However, they're not giving us the intercepted arc. They're giving us the other arcs, right? So all we have to do is find the other angle because they are giving us the intercepted arcs for the other angle on the other side, right? So we'll find angle 1 by adding the two arcs together and divide it by 2, and angle 1 would be 63 degrees. Well, if angle 1 is 63 degrees, we can just subtract it from 180 to find angle x, which is 117. One more example. This one, we are given the central angle, which is 60, and one of the arcs is 55. And then the other arc, GF, is 5x plus 13. We just have to set up the equation and solve for x, okay? So follow the formula. The formula says the central angle, which is GEF, so the measure of GEF equals to half of the sum of the intercepted arcs. So the intercepted arcs would be HL and GF. So you add those together, divided by 2. So I'm going to follow this formula and substitute everything in, okay? So the measure of GEF is 60, and then equals 1/2 times HL here, arc HL is 55 degrees, all right? And then plus GF, arc GF is this expression, 5x plus 15. So I just pretty much substitute everything in. And then now you're going to combine like terms. So take care of your parentheses here. You add the 55 and the 15 together, you get 70. Now you're going to get rid of this 1/2 by multiplying it by 2 to the other side. So you get 120 equal 5x plus 70. Now you're going to get rid of this 70 by subtracting it from 120 to give you 50. And then finally you divide it by 5 to get x by itself, and 50 divided by 5 will give you 10. So the value of x is 10 in this problem. Lastly, we're going to talk about the outside angles, okay? And the outside angles could be formed by many different types of segments. It could be two secants that meet on outside of the circle. So you form that angle A right here. Or it could be two tangents that meet and form that angle A right there. Or a combination of each one of them, a secant and a tangent, right? They could meet and form. It doesn't matter what lines make the angle, as long as the angle is outside, the formula is the same. So what does the formula say? The formula says the angle on the outside of the circle is half of the difference between the two arcs. So you take the big arc, you subtract the little arc, and then divide it by 2 to give you the outside angle, right? So unlike the inside angle, you add the arcs and divide it by 2. The outside angle, you subtract the arcs and divide it by 2, okay? They're contrast, sort of. All right, so you're subtracting BC from DE and then divide it by 2. So you're going to do 125 minus 27 divided by 2. Now subtract first and then divide, okay? Because that's done first, okay? 98 divided by 2 will give you 49 degrees, which is angle A. Okay, so the formula is subtract the arcs divided by 2. All right, here's an example. This example has expressions, so we'll have to set up our relationship and then substitute, solve, and then plug it in because it's asking us to find the measure of angle Q. The measure of angle Q, well, angle Q is the outside angle. 190 is the big arc. 13x minus 7 is the little arc. So we're going to do angle Q equals the major arc minus the minor arc divided by 2. That's our formula, right? The difference between the two arcs divided by 2. Then I'm going to substitute in. Angle Q is 5x minus 5. Major arc is 190. Subtract minor arc. Now, you guys be careful right here. When you're subtracting a quantity, you have to put that quantity in parentheses because this minus is going to affect everything that is in there, right? Inside the parentheses, okay? And then divided by 2. Now, there are multiple ways to do this, right? But the easiest way, I think, is to get rid of this dividing by 2 right here, right? That 1/2. So I'm going to move this 2 to the other side by multiplying it the other side by 2. So I get 10x minus 10 instead. And then here, the 2 is gone, right? Now, the next step I'm going to do is, at the same time, I'm actually got rid of the parentheses by distributing this negative sign through. And as you can see, when I distribute the negative sign through, I get a plus 7 instead of a minus 7. Guys, it's a very common mistake that students make all the time. They forget about that negative in front of the parentheses. All right, so now I'm going to combine like term. 190 plus 7 is 197. And then now I'm going to add the 13x to the left-hand side and then add 10 to the right-hand side. So I'm sort of moving the terms to their respective sides, right? So I get 23x, and then over here I get 207. And then last step, I divide by 23 to get 9. Now, after you get the value for x, don't stop there because the question asks you to find the measure of angle Q. So what you do is you go back to angle Q and you substitute the 9 in for x. So you get 5 times 9, which is 45. Take away 5 will give you 40 degrees. Okay. So far you've seen all different examples for all of those angles, a variety of them. So I hope this video has been helpful in explaining how to deal with these angles. So, and I also have a little summary chart here if you want to jot it down on your notes or something, or take a picture of this. To find the central angle, it's equal to the arc. To find the inscribed angle, it's half of the arc. To find the inside angle, it's half of the sum of the arcs. And then to find the outside angle, it's half of the difference of the arc. So that's pretty much in a nutshell. So hopefully that's gonna make it easier for you to understand. All right, thank you for watching, you guys, and I will see you in the next video. Bye bye.